Hey, let's take a look at the solving algebraic fractions, starting with these three examples. And I am going to start with all three examples because I want to show you that I always do the same thing to start. When I see algebraic fractions, the first thing I think to do is multiply it by the denominator. Now, in these three equations, there are actually two fractions in each of these equations. So I'm going to need to multiply all of the terms by the denominators of both of the fractions, starting with this one in red. First, I'm going to multiply everything through by the x and everything through by the x plus 3, using brackets to make sure it's kept clear. See, I multiply the first fraction on the top by x and x plus 3. I multiply the second fraction on the top by x and x plus 3. And I multiplied the other side, which keeps this as a balanced equation, by x and x plus 3. I'm going to do that to the blue one as well. So I'm going to multiply all three terms by x plus 6 and x plus 3. Here I multiply the first fraction on the top by x plus 3 and x plus 6, keeping it in brackets so that I know that I need to expand that out later. The second fraction I was multiplying on the top also by x plus 3 and x plus 6. And to keep this a balanced equation, I need to do whatever I've done to this side, so multiplying by x plus 3 and x plus 6. I have to do the same to the other side. So my 2 was also multiplied by x plus 3 and x plus 6. Same thing with the third equation. This is going to seem a bit repetitive to you, but that's to show to you that we always do the same thing. I'm going to go ahead and multiply all three terms by the denominators of both of those fractions. So this first fraction, I'm going to multiply the 5 on the top by both x and 2x plus 1. In the second fraction, I'm multiplying the 1 on top by x and 2x plus 1. And on the other side of the equation, where I had this negative 3 before, I have to multiply negative 3 by both x and 2x plus 1. Again, I put everything that I was multiplying through in brackets so that I'll remember to multiply it through after. Okay, now you might be wondering why I did that, because this is looking a lot more confusing down here than it did up here. And let me just show you why. The whole problem here is that they're fractions, and fractions are difficult to work with. But when we multiply a fraction by the same thing that we've got in the denominator, we can actually simplify that fraction. Let's look at the red one again. The red one simplifies to this, no more fractions, and let me just quickly show you why. I had 2x times x plus 3 over x plus 3. I had the same expression on the top and the bottom. I could divide the top by x plus 3, which is why there's no longer an x plus 3 here, and divide the bottom by x plus 3, which is why this is no longer a fraction. So they canceled out. Same thing for the second fraction. I had an x on the top and an x on the bottom, so they canceled out, and I was left with just 1 times x plus 3, which of course is just x plus 3. And then on the other side of the equation, I just went ahead and multiplied that through. So 1 times x is just x, and I times x by x, which is x squared, and x times 3, which was 3x. Okay, that is not finished. I'm just trying to explain why we multiplied by the denominators first, then we have to worry about working the rest of this out. Okay, let's look at the blue ones now. How does this become simplified? It becomes a lot more simple if you cancel out the common factors on the top and bottom of these fractions. This first fraction has both x plus 6 on the top and x plus 6 on the bottom, so those will cancel out, leaving me with just 2 times x plus 3, which is 2 times x is 2, and 2 times 3 is 6. I kept that in brackets here specifically because the next fraction was being subtracted. So I don't want to get any confusion with my signs here. So I've got this was my first fraction minus this is my second fraction. That's how it's simplified. Because I had x plus 3 on the top and x plus 3 on the bottom, they canceled out, and I was left with just 1 times x plus 6 on the top. So 1 times x plus 6 is just x plus 6, and I had minus before this fraction, so I made sure I kept that in brackets and I put a minus in front of it. And finally, on the other side of the equation, I had 2 times a bracket times another bracket. And I know there's a lot of confusion here. A lot of people are trying to multiply 2 by everything. Remember that whatever is in front of the bracket only needs to multiply by the bracket that it's touching. The 2 is not touching the last bracket. However, I started multiplying this through the easiest way that I thought would be, and that is by first expanding the brackets. So first I did x plus 3 times x plus 6, and I left the 2 out front. And the next step, I could multiply the 2 through into the 3 terms of the brackets that's left behind it. Okay, again, this is not finished. You can see that I still have something to solve. When I'm solving an algebraic fraction, I'm looking for an actual answer. What could x possibly be to make this equal to 2? So here, I can see that I still have an equation to solve, and I'm noticing that it's got an x squared term in it. That's going to be a quadratic, so I got quite a lot of work to go still, but at least this is simpler than what we started with. Again, with the green equation, I've multiplied all terms by the denominators of both fractions, and that makes it simplify nicely to this. Notice I had 2x plus 1 on the top, 2x plus 1 on the bottom. Those disappeared, leaving me nice and neat with just a 5 times x, 5x. And here I had x on the top, x on the bottom. Those ones cancel out, and I just have 1 times 2x plus 1 on the top. Now be careful because it was minus. I'm subtracting this fraction, so I put a minus here and I kept this in brackets. And on the other side of the equation, I had minus 3 multiplied by x multiplied by 2x plus 1. And I just multiplied the x by the 2x and the x by the 1, leaving the minus 3 out front, which I'll multiply through later. But you see, I no longer have any fractions to worry about, so that's all I needed to do to sort out my algebraic fractions. However, I still need to solve. So let's have a look at how we could solve the red equation. This is the working that I showed you before, and this is how it's simplified down. So I've got an equation which no longer has fractions in it, but I can see the beginnings of a quadratic forming here. I've got an x squared term. So that means to solve this kind of equation, I need to bring everything to one side and leave 0 on the other side. So I'll start doing that. I have, first of all, simplified this. 2x plus x makes 3x plus 3. And that's equal to x squared plus 3x. There was no need for me to have those brackets there anymore, so I just took them away. Now I want to make this equal to 0, so I'll leave the x squared and the 3x where they are, and I'll move these to the other side. So that's going to be 0 equals x squared plus 3x, same as I had above, but I've taken this across. It was positive, so now it's minus 3x, and that was positive, so that's now minus 3, and I can simplify that. A quadratic usually has 3 terms, an x squared term, an x term, and a number term, but I can see that my x term, 3x minus 3x, is going to become 0. So I've got x squared minus 3. Now you might be thinking 2 terms, a difference of 2 terms, but it's not a dots. It's not a difference of 2 squares. So I'm not going to set up 2 brackets to factorize this. I'm just going to go ahead and try and get x on its own. So I'll move this 3 over to the other side again. That's going to be plus 3. So 3 equals x squared. And to get rid of the squared, I just need to square root. So the square root of 3. Now remember, when you square root a value, it could have a positive answer or a negative answer, which is why my x value is going to have 2 possible answers, just like we would generally expect for solving a quadratic. So our 2 possible answers is either positive square root of 3 or negative square root of 3. Now this is the square root of 3. It's an irrational number. It doesn't have any pattern in the decimal values, and it continues on forever. So we are going to need to round that. So I've got my rounding symbol here. And that rounded to 3 significant figures is 1.73 with a 2 after it, stays a 3. Now I could have left my answer like this as well. This is a thirds answer, and this is a rounded to 3 significant figures answer. Both are acceptable. This one's exact. This one's been rounded. But just to be really clear, this is 2 answers. One of the answers is x equals 1.73, and the other is x equals negative 1.73 to 3 significant figures. We could also say x equals the square root of 3 or x equals negative square root of 3. Having a look at this second example here, again, remember I started the same way as with the red example by multiplying all 3 terms through by the denominator, and it gave me this slightly simpler looking equation. I still see this x squared term here, so I'm thinking this is going to be a quadratic, and to solve a quadratic it first has to be equal to 0, and then I can either factorize or use the formula. But it must be equal to 0 first. So let's first simplify what we got over here on the other side. I've left this in brackets specifically because there's a minus out front. I'm subtracting the second fraction from the first one. So that means I'm going to minus the x and I'm going to minus the 6. So I'm going to do 2x minus x, and 6 minus 6, that's just going to give me x, because 2x minus x was x, and 6 minus 6 is 0, so that disappeared. Also, I've multiplied through this 2 with my quadratic here, so I did 2 times x squared, 2 times 9x, and 2 times 18, which gave me 2x squared, 18x, and 36. Now, it's still not equal to 0, so I need to bring that x across. So I'm going to minus it on the other side. I went ahead and put it right here in the middle because I knew that my quadratic has an x squared term, an x term, and a number term. And I'll simplify the x term in the middle here. 18x minus x is going to be 17x. So that's 0 equals 2x squared plus 17x plus 36. Now you might have noticed my thought bubble up here because I knew in advance that I was going to have to deal with this kind of quadratic. Notice what kind of quadratic it is. What makes this difficult is that there is a number in front of the x squared term. Either I need to be able to factor that number out, so divide everything here through by 2, but that would leave me with a decimal value here, so I can't do that. So I'm going to need to split the middle term. To split the middle term, I take the first coefficient, so the number in front of the x squared term, and I multiply it by the last coefficient, so the number that's on its own. And then I find a number that multiplies to be that answer, but adds to make the middle term so that I can split that middle term. So I'm going to do 2 times 36 is 72. And think of all the numbers I can think of that multiply to make 72. And I'm looking for one pair that also adds to make 17. So the easiest factors I can think of is 1 times 72 makes 72, but 1 plus 72 makes 73, so that's not going to work. I can also divide 72 by 2. 2 times 36 makes 72, but 2 plus 36 is 38. Not going to work. So I keep going. 72 also divides by 3, and it's 24. But 3 plus 24 is 27. I'm still way off. Next, I can divide 72 by 4, and that gives me 18. But 4 plus 18 is 22. Let's keep going. I can divide by 6. 72 divided by 6 is 12. But 6 plus 12 is 18. And I'm starting to doubt myself here because I've tried so many pairs and I still haven't found a match that will add to make 17. Well, let's keep going. Surely there's one more. 72 divides by 8, and the answer is 9. 8 times 9 makes 72, and 8 plus 9, wouldn't that always be the case? The last one we try adds to make 17. So we can split that middle term into 8x and 9x. So I've written the same quadratic as I have above. The only difference is instead of writing 17x in the middle here, I split it out into 8x and 9x. The reason I did that is so that I can factorize by parts, because I couldn't factor the whole quadratic all the way through, but I can factorize the first two terms, find a common factor. They both divide by 2. They both also divide by x. I'm going to factor out 2x. And looking at the last two terms, they both divide by 9. So I'm going to factor by parts. I factored the 2x out of the first two terms. 2x times x would make 2x squared, and 2x times 4 would make the 8x. And I factored the 9 out of the last two terms. 9 times x would make 9x, and 9 times 4 makes 36. So notice that I've got the same brackets here. That must be the case, otherwise I've done something wrong. I need the brackets to match so that I can do the next step, which is regrouping. I need to do 2x times x plus 4. I also need to do 9 times x plus 4. So why not put that together? 2x plus 9 times x plus 4. This is exactly the same as what you got above. It's just a lot tidier because I've regrouped it. Up above, I would have done 2x times x and 2x times 4 plus 9 times x plus 9 times 4. Same thing down here, just following the loops. 2x times x, 2x times 4. Then 9 times x and 9 times 4. So I factorize this as much as I can. I've got a quadratic, a factorized quadratic equal to 0. That means either this is 0 or this is 0, because the only way two things can multiply to make 0 is if either one of them is 0. So let's start with if 2x plus 9 equals 0. That's a nice linear equation that you can rearrange. Get x on its own. First I'll take the 9 across and minus it. Plus 9 becomes minus 9. And then I'll take the 2 across. It was multiplied, so I will divide. So that's negative 9 over 2. Or as a decimal, that would be negative 4.5. Then I'll try that with the second equation, or the second bracket, excuse me. That is 4 plus x, or x plus 4, must be equal to 0. If the first bracket's not equal to 0, the second bracket must be equal to 0. That's the only way I could say that this bracket times this bracket will multiply to make 0. So x plus 4 equals 0, which means that x on its own must be equal to negative 4. So those are my two possible values for x. You can go ahead and check them by substituting them into the equation. So 2 over negative 4.5 plus 6 minus 1 over negative 4.5 plus 3 should equal 2. Or I try with the second answer. So if x is negative 4, I'll do 2 over negative 4 plus 6 minus 1 over negative 4 plus 3. That should also equal 2. Finally, our last one, our green equation here. Again, I started the same way. I got rid of these algebraic fractions by multiplying everything through by the denominators, and it gave me this. Once again, this is starting to look like a quadratic. I've got an x squared term here, so I want to make sure that this is simplified and equal to 0 before I try to solve it. Starting by simplifying this, again, I left the brackets there on purpose because I saw that this was minus. I'm subtracting the second fraction. So I'm subtracting the 2x, and I'm also subtracting the 1. So I'm doing 5x minus 2x, which is 3x, and it's not plus 1 because I'm minusing the 1, it's 3x minus 1. Okay, and then on the other side of the equation, I multiplied that through by the negative 3. I did negative 3 times 2x squared and negative 3 times x, giving me negative 6x squared minus 3x. Still looking like a quadratic here, so I better move this over to that side so that I left 0 on one side, and then I can either solve by factorizing or by the formula. So taking the 3x to the other side, I'm going to minus it. Taking the 1 to the other side, I'm going to plus it. So I end up with negative 6x squared minus 3x minus this 3x again and plus the 1. So that's going to be negative 6x minus 6x plus 1. Now I want to solve this quadratic, and once again it looks like a difficult one because there is a number in front of my x squared term. So I'm thinking, could I maybe split the middle term on this one? I certainly can't divide everything through by negative 6x. I could divide the first two terms, but not the last one, so I don't have a common factor here. So I'm going to have to use a different way of solving this. Splitting the middle term, that would again mean multiplying the first term by the last term and finding a number that has that product, so that multiplication answer, and adds to make the middle number. So negative 6 times 1 is negative 6, and I can try all of the possible factors of negative 6, keeping in mind that if it multiplies to make a negative, one of the factors should be positive and one should be negative. And if it adds to make a negative, then the bigger number should be the negative one. So my factor pairs are 1 and negative 6, making the bigger number the negative number, or 2 and negative 3, again making the bigger number the negative number. But these would add to make negative 5, not negative 6, and these would add to make negative 1, not negative 6. So there is no way for me to split this middle term so that I can factorize by grouping in any nice way, right? So I'm going to have an answer that's probably going to be a decimal number. I'm going to get a decimal number answer. I'm thinking quadratic formula. That's going to give me an answer to 3 significant figures. So let's try that. Here's my quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a, where a is the first term in front of the x squared, including the minus sign. B is the second term, the one that's with the x, including the minus sign. And c is the number that's on its own, and it's positive 1. So substituting that into the quadratic formula, and that can get you marks on an exam, so do show the working of substituting in, would be this. Negative b is negative of negative 6, so I put that in brackets, even though I know that negative is going to make that positive 6. I'm showing that so the examiner knows I've substituted incorrectly. B squared is negative 6 squared. I need brackets there because I know that negative 6 times negative 6 makes positive 36, and if I don't put the brackets, I'm only going to be squaring the 6, and I'll be putting a minus in front of it, so that'll be wrong. Minus 4ac, so a is negative 6 minus 4 times negative 6, and c is positive 1, so c is 1. Okay, over 2a. 2a is 2 times negative 6, and that works out to be either negative 1.145497224. Again, I wouldn't write all of this out. I just need to round to 3 significant figures. This is my answer when I'm adding, and that works out to be the square, approximately negative 1.15, because the 4 with a 5 after it rounded up. If I minus here, I get the answer. X is equal to 0.145497224. Again, I wouldn't write the whole thing out. I would just round to 3 significant figures. The 0 is a leading 0, so it's not significant. I see 1, 4, 5 with a 4 after it. That's not big enough to make it round up, so it's 0.145. Okay. Now, it might surprise you that when I minused, I got this positive answer, and when I added, I got this negative answer, but that's simply because I've got negatives in this question. So I might be minusing a negative, or I might be adding a negative. Okay. Now, here are the other 3 examples that I'm going to leave you with. Remember that you can solve them all 3 the same way as we did the previous ones. Our first step should always be to multiply all terms by both of the denominators. So the 3 is going to get multiplied by the x minus 4 as well as the x. The 5 is going to get multiplied by the x minus 4 as well as the x. And the 2 is going to get multiplied by the x minus 4 and the x. Same with these 2 examples. Then you need to simplify your fractions, which will involve canceling out the expression in the denominator. If I multiply the top by x minus 4, I'll have x minus 4 on the top, and on the bottom, that'll cancel out, and that's what's going to get rid of my fractions. Then I'm going to expand the brackets, but pay close attention to the plus minus signs, especially with things like this, where I've got these minus and then the next fraction. Leave that minus in front of the fraction, or in front of the set of brackets that you've got, and remember that you're subtracting everything inside that bracket. So if you're subtracting a positive, we're minusing it. If you're subtracting a negative, we're adding it. Now set the resulting quadratic equal to 0. Generally speaking, these ones almost always end up as a quadratic because we're ending up multiplying bracket times bracket. So if you've got a quadratic, if you see an x squared term, rearrange it so that you've got 0 on one side of the equation, and then solve the quadratic either by factorizing or by the quadratic formula. If they don't say that you have to factorize, you don't need to, but often it's easier to factorize than use the formula. It's very easy to make calculating mistakes. Okay, so if you have not yet done these examples, take a minute to do them now. So hit pause, because I'm going to put the answers up in just a minute. I hope you've hit pause. Here come the answers. So I've color-coded them again here, orange, blue, and purple. The answer to the orange one is x equals 5 or x equals minus 2. You can try those 2 answers by substituting them in here, and they should give you the answer 2. So I put 5 in here and 5 in there, and that gives me an answer 2. Or I put negative 2 in here and negative 2 in there, and that gives me an answer of 2. If you didn't get these answers, you're going to have another look over your working and make sure that you've dealt with your signs correctly, you've expanded your brackets correctly, you've factorized correctly, and you don't have any calculation errors. The second equation is just x equals 1. And you can substitute x equals 1 into both of these fractions, and you'll see that it gives you an answer of 0. Note there's only one answer to this because when we expanded this out and we went to solve it, it didn't actually form a quadratic. Somehow it canceled itself down and there was no quadratic there to solve. It was just a linear equation. Now this last one, x is either 3 over 5 or x equals 4 over 3. Again, you can check those answers by substituting them in here, and you should get an answer of negative 5. And if you've got something other than that, go over your working and let me know if you need any help.